If you observe the nature around, you will see that most of the things created by the God Almighty are based on the principles of trigonometry. Soon after his arrival on the planet Earth, the man began to utilize the trigonometry in one way or the other in order to construct various things for his life. Looking back at our history, the historical pyramids and Babylon gardens are the main examples which prove that Pythagoras' theorem had already been known more than 1,000 years back. Now let's see the application of trigonometry. As you all know that in some situations, direct measurements are not only difficult but even impossible. It is not a practical idea for someone to climb up the cliff just for the sake of taking its height. Therefore, trigonometry is a powerful tool for making indirect measurements. It plays an important role in the field of surveying, navigation, engineering, and many other branches of physical sciences. Suppose you are standing on one side of the river and want to know its width. What are you going to do? Well, take a measuring tape and measure it. No, here you will apply the trigonometry rule. Bridges are also constructed on the principles of trigonometry ratio.
Assalamu alaikum viewers. Our today's topic is trigonometry, exploration of knowledge about sides and angles of triangles. Trigonometry is a combination of three words. Tri means three, gone means angles, and meteron means measurements. We are mostly concerned about the right triangles having one angle equal to 90 degrees. We have got many interesting examples for you in this program today.
1 degree is defined as the 3/60th part of the circumference angle, and a radian is defined as the central angle made by an arc when its length is equal to the radius of the circle. A relation between a degree and a radian is defined as we convert different system of units to the other, like we convert kilometer into meters. Similarly, we will convert degrees into radians and radians into degrees. Let's see how. As you know, if we are given a circle, then it can be divided into 4 parts and each one is of 90 degrees. So the total angle of a circle will be 360 degrees. And if we are going to measure it in radians, that should be 2 pi radian. So 360 degrees are 2 pi radian. Then pi radian is equal to 360 degree by 2. That is pi radian is equal to 180. And if we want to find 1 radian, then 1 radian is equal to 180 by pi. Now we will put the value of pi, that is 180 divided by 3.1415. So 1 radian is equal to, if we divide it, then it will give us 57 degree 0.1295, like that. Similarly, by taking this equation again in consideration, you can find the value of 1 degree. That is equation 1. So equation 1 implies that 1 degree is equal to pi by 180. That is 1 degree is equal to 3.1415 divided by 180. That is, this will give you the value, that is 1 degree is equal to 0 point something like that.
We hope you must have a pretty good idea as to what is the relation between the radian and the degree. Yes, you are quite right. The relation between the two is their mutual convertibility. I mean, we can convert radian into degree and reciprocally degree into radian. Now let's see what is the relation between the arc length and radian measure of angle.
This is a circle we are having. Then this point is A and this point will be B. So this is your arc which you have considered. Let's suppose this is a circle and this is the radian measure of angle theta. That is your L, that is length of arc. So if we want to find the relation, then the ratio of in a triangle, you know that the ratio of all the corresponding sides must be equal. So in this case, that is L over 2 pi r. Ratio of the arc length and the circumference is equal to theta over 2 pi. That is the ratio between their corresponding angles. So L is equal to, when we take it up, that is 2 pi r into theta on the other side of the equation. Then this 2 pi is cancelled with this 2 pi, and that is L is equal to r theta. Now this is an important formula, and the relation between arc length, radius and angle of radian. This was the relation between arc length and radian measure. Can you find the area of a sector with the help of this formula?
We know that area of circle is equal to pi r square. Then area of circle ratio area of sector is equal to 2 pi ratio theta. So that area of sector over area of circle is equal to theta over 2 pi. Then area of sector over pi r square is equal to theta over 2 pi. Area of sector is equal to theta into pi r square over 2 pi. So we can find area of sector is equal to 1 over 2 r square theta.
Well, this was the area of sector of a circular region when its radius is given. Now, if moon is observed from Earth, it makes a certain angle for the observer. Now let's see, by measuring the distance between the Earth and the moon and by using the relation between the arc length and the radian measure of angle, how one can find the diameter of moon.
This is your Earth and this is moon. The angle subtended by the moon is given. This will be this angle, that is theta is equal to 0.5 degrees. Now as you know, we have to change this degree into radian. So what we will do, we will multiply this 0.5 into 0.01745, and that will give you 0.00875 radians. That is the angle. Similarly, the distance between Earth and Moon is 38440 kilometers. This is the distance between Earth and Moon. That is your R. That is 38440 kilometers. This is your point A and this is your point B. This line is up till here and this is up till here. This is white line, so this is overlapped. That is why these 2 points are. We will make a line. That will be the diameter, and diameter, you know that the line which cuts the circumferences and passes the center of the circle. That will be the center. This is actually arc, circular arc. But when this distance is very large as compared to the diameter or as compared to this line, so this arc must be equal to a straight line. That is, arc AB is equal to L, that is equal to diameter of mu, which you want to measure. By applying the formula, L is equal to R theta. Putting the values, that is 384400 kilometers into 0.008725. That was your theta in radians. This will give you, by multiplying, 3354 kilometers, which is your required diameter of mu.
This was some figurative work related to trigonometry. Now we'll give you an idea about the base of trigonometry, that how it started, what are the trigonometric ratios, and how we can find these ratios by taking right triangle in consideration.
If we have a right triangle, and the right triangle, you know that if one angle is 90 degree, then it is called right triangle. That is A, B and C. Now, if this is the angle theta you want to measure, then opposite to B, that is 90, this side is called hypotenuse, and opposite to that one, that is theta, is perpendicular. And the remaining side is called base of the triangle. So sin theta is the ratio of perpendicular over hypotenuse. Similarly, cos theta will be the second fundamental ratio, that will be base over hypotenuse. And the third fundamental ratio is tangent theta is equal to perpendicular over base. And then there are three derived quantities, that is cosecant theta. This is the reciprocal of this one, that should be hypotenuse over perpendicular. Similarly, we have secant theta, that should be the reciprocal of cos, that is hypotenuse over base, and the reciprocal of tangent, the derived quantity will be cotangent theta, that is equal to base over perpendicular. Well, viewers, here I will tell you an interesting and important sentence which you can learn, and by that sentence you can easily remember these fundamental identities. Some peoples have curly brown hair through proper brushing.
Well, I see you are getting more and more familiar with trigonometry. So now we'll tell you about some fundamental identities of trigonometry driven with the help of trigonometric ratios.
Consider right triangle once again, that is 90. Let's suppose these are your axes, that is x-axis and y-axis. So this should be your x, this will be your y, and that is your r. Let's suppose this is vector r. So by applying Pythagoras theorem, that is hypotenuse square is equal to perpendicular square plus base square. That is, your hypotenuse is r square, your perpendicular is y square, and your base is x square. Now by dividing this equation, r square on both sides. So r square over r square is equal to y square over r square, that is r square is divided by each entry. That is, this should be 1 is equal to y over r whole square, because there were individual squares with both of them. Now, considering this triangle once again, you can easily see that y over r is your perpendicular over hypotenuse, that will be sine. since y over r is equal to sine theta. Similarly, x over r is equal to cos theta. Then if we put these values, then 1 is equal to sine square theta plus cos square theta. That is your first fundamental formula or first fundamental identity. That is sine square theta plus cos square theta is equal to 1.
Well, viewers, how did you find these fundamental identities of trigonometry? I hope really interesting. Now let's see how they can be used in solving practical problems, because practical work makes our observation more reliable and gives confidence towards knowledge.
Take left hand side, that is equal to secant x minus cos x over 1 plus cos x. You know secant is equal to 1 over cos minus cos x divided by 1 plus cos x. Now here you will take LCM in numerator, that will be cos x. So this should be 1 minus cos x into cos x, that should be your cos square x over 1 plus cos x as it is. Now there are 3 lines, 2 denominators, so we will change them. 1 minus cos square x over cos x into 1 plus cos x. Similarly, by using the same formula, that is a square minus b square is equal to a plus b into a minus b. That is 1 plus cos x over 1 minus cos x over cos x into 1 plus cos x. Now this 1 plus cos x is cancelled with this factor, that is equal to 1 minus cos x over cos x. So this will divide 1 over cos x minus cos x over cos x. That is 1 over cos x is secant x minus cos x over cos x is 1. That is equal to right hand side.
Let's watch an interesting application of trigonometry. Consider point A on one side of the river where you are standing. Mark another point C on the same side. Measure distance between C and A and label it as L. Then draw a perpendicular on point A and join it to point B on the other side of the river. Denote it by W. Join B to C and extend it to point D. Now measure the angle DCA. Suppose it is 120 degree. Then subtract it from 180 degree to get angle BCA, which is equal to 60 degree. Now apply tangent theta, which is equal to W by L. This implies that W is equal to tangent theta into L. Now putting the value of theta and L, this gives the value of W, which is the required width of the river.
Measurement of angle is another important feature of trigonometry, and they must be measured with great care. Now let's see what are the general rules we can use for measuring angles. We have positive and negative measurements, as well as clockwise and anti-clockwise measurements of angles. And these are relatively new concepts for you.
Consider this figure, that is your angle 0. If you start from here, that will be pi by 2 or 90. This will be pi are 180, that is in degrees and radians, 3 pi by 2, that is 270 degree, and then it is 2 pi or 360 degree. So if you go like that, then this will be your first quadrant, this will be your second, this will be your third, that is obviously fourth quadrant. So in first quadrant, all are positive, sine, cos, tangent, whatever they are, they will be positive. In second, only sine is positive and all the others are negative. In third, tangent will be positive and all the others will be negative. So in between 180 and 270, only tangent is positive, all the others are negative. Similarly, in fourth quadrant, only cos is positive and all the others are negative. That is, in between 270 and 360, only the values of cos are positive and all the others are negative. So if in reverse order you write, then it will be a word acts. That is, in first quadrant, all are positive. And if you goes like that, then this will be your second, that is fourth one. So in fourth, cos is positive, all the others are negative. Similarly, in third, tangent is positive and all the others are negative. In second, sine is positive and all the others are negative. Well, viewers, you must keep in mind that for some specific angle, there are some specific values. The angles are 0, 30, 45, 60, 90 and so on. So you must keep in mind these values and you will apply further in your problems.
Values of some special trigonometric function. Here is some values. Sine 0 degree is 0, sine 30 degree is 1 over 2, sine 45 degree is 1 over under root 2, sine 60 degree is under root 3 over 2, sine 90 degree is 1 and sine 180 degree is 0. Cos 0 degree is 1, cos 30 degree is under root 3 over 2, cos 45 degree is 1 over under root 2, cos 60 degree is 1 over 2, cos 90 degree is 0, cos 180 degrees minus 1. Tan 0 degree is 0, tan 30 degree is 1 over under root 3, tan 45 degree is 1, tan 60 degree is under root 3, tan 90 degree is infinity, tan 180 degree is 0. Now Mr. Amir will tell you how we can prove.
Here we are having a question. Cos 90 degree is equal to 1 minus 2 sine square 45 degree. So we are having two sides, that is left hand side is equal to cos 90. As she told you in the table that cos 90 is 0. So its left hand side is 0. Taking right hand side, 1 minus 2 sine square 45 degree. And in the table we have seen that sine 45 is 1 over under root 2. So by applying this value, 1 minus 2 into 1 over under root 2 whole square, because that was sine square 45. So 1 minus 2 into 1 over 2. That is, this 2 is cancelled with this 2. That is 1 minus 1 is equal to 0. So you can easily see that right hand side is equal to left hand side. Both are 0.
Well, viewers, we hope that all the concepts regarding trigonometry as conveyed to you in this program are quite clear in your mind now. Thanks for being with us. Allah Hafiz.